Hi guys, welcome back to Leaving Cert Plus. This is lesson 1.3 part B. We're looking at cross multiplying and we'll also touch on the word cancel. So there's some confusion around cross multiplying. What does it actually mean? When can you use it? This is the situation when you use cross multiplication. What we have here, we have two fractions equal to each other. So in that situation, cross multiplying basically just means you take this bottom guy and you multiply him by him, and this bottom guy and you multiply him by him. And that's really it. So take, for example, if we had something like, it would say 3 over x is equal to 7 over y. What we could say in that case is 3y is equal to 7x. Okay, and that's the situation where you can use what we call cross multiplication. And just to look at actually what's happening here, as we've seen in the last lesson, when we don't want this division to happen, we multiply by what's on the bottom. So you don't want that division to happen, so you multiply across by y. So that means you got the y beside the 3 there. And at the same time, we're doing, from the point of view of the x, we don't want that division of the 3 happening with the x. So we multiply across by x. And when you multiply across by x, that gets rid of this fraction. And when you multiply across by y, it gets rid of this fraction. So really all you're doing is saying, I want to multiply by y, and I want to multiply by x. And so I'm multiplying by both of them at the same time. That's really what cross multiplication is. Now, if you look at an example, something like this is often where people get mixed up and they're saying, okay, right, I'm just going to cross multiply these to get rid of the fraction, which is incorrect. So in this situation, you might see an annotation like this drawn, where you have a plus sign and it's not an equals between. And you might be thinking, well, I use cross multiplication there. What you're doing is you're creating a common denominator, which makes complete sense. So we could say 5 multiplied by the 2x. That's correct. So 5 by the 2x. And you could say 4 by the 3x. So 4 multiplied by the 3x. So you've done some sort of cross multiplication there, but you need to draw that under or over the product of 5 by 4, which is your 20. And that's fine. If you want to call that cross multiplication, you can. It's not really. This is a situation where you're using cross multiplication where you have two fractions equal to each other. But just don't get mixed up. Often people draw that line and they just put it equal to 3. Okay, so this here is incorrect. That's not right. It needs to be over the common denominator which you've created, which is 20, and then you continue on with your question. So in a situation like this, I've got a question. Can you use cross multiplication? Yes, you can. So I can multiply across by 4 and I can multiply across by 7. And that is the process of cross multiplication. So I could say it's 7 times x plus 1 and I could say it's 4 times x, and then I can continue on with my question. Okay, and you can go ahead and solve for x there. Okay, so here are two questions here. I just want you to pause the video and I want you to think about whether you can use cross multiplication or whether you have to come up with a common denominator. So just try come up with the next line for each one of these questions. You don't have to finish it out. Okay, so looking at the top one here, here's a situation where we can use cross multiplication. I'm going to multiply the 4 by the x and the 8 by the 2x plus 4. So I got 8 by 2x plus 4, and I've got 4 multiplied by the x. Do I need a sort of fraction here? No, I don't, because we just multiplied across by 4 to get rid of this guy, and then we multiplied across by 8 to get rid of this guy. So hence it makes complete sense. Looking at this situation here, I can't just multiply the 4 by the 3x and the 5 by the 2x and forget about these fractions because they're being added together. I need to come up with a common denominator of 20. So then it's the 5 by the 2x, that's a 10, 4 by the 3x, which is a 12x, and that's equal to 3, and I continue on the question from there. So finally then, for 1 second, I just want to address the word cancel and just your understanding of that word and how we might use it when we're kind of trying to make maths more understandable. So if we look at a situation like this, you've got x plus 1 on top and on the bottom. So in my case here, I'd say I'd cancel them off. But really what that means is we're saying it's x plus 1 over x plus 1. So something divided by itself, that's just equal to 1. So what's 5 divided by 5? It's just 1. So if I have a 1 there, I'm just going to say, well, look, if I had x minus 7 over 2x plus 6 left, and if I multiply that by 1, it's just going to be itself, so we just don't talk about it. So cancelling off, in this case, you've just got something over itself, it's equal to 1, something multiplied by 1 is just itself, so we don't talk about it anymore. Now, in a situation like this, you probably won't hear it as often, but some people might say, well, look, we have the same thing on both sides of the equals, let's cancel them off. But as we learned in the last lesson, or in the previous lesson, what we're actually doing here is we're taking x from both sides. So if I took x from the left-hand side, and if I took x from the right-hand side, that would get rid of this x, and this would get rid of that x, and I'd be left with minus 7y is equal to 6. But they are just two situations. You might hear the word cancel being thrown around, but I suppose it's really important that you understand the maths behind it. But that's really all for this lesson, just those two kind of areas that people go wrong. Well, cross multiplication is the main one, and just understanding cancelling. So I'll see you again at the next lesson. Thanks for watching.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.